And so our next talk's from Sesame.
Good morning, everyone. This is Malik from Sesame. So I'm going to talk about the introduction to the data catalog services and use case at Sesame for today. I think I'm going to use this. Okay. Okay. So first of all, I'm going to give a brief and overview of Sesame. Sesame located in the Middle East, in Jordan, and we are open to doors in Open Sesame project to the rest of the world. So we are always open to collaborate, and it's a third generation light source, as I mentioned here. So Sesame is going up in 2017, and we have now running 5 beamlines. I'm going to the another slide. Okay, here's the beamlines we have. We have 5 running beamlines. One of them is IR, and the second is XAFs, HISP, Beats, and we are planning to have another 3 beamlines. One of them is under design, and 2 is planned to do. I am a part of computing group at Sesame. We are 3 people, me and my colleagues Salman and Ibrahim. So what we are doing in Sesame as a computing group, here you see the infrastructure, handling all the infrastructure in Sesame. We have more than 200 servers, hybrid servers, Linux and Windows. And we handle either more than 15 terabytes of server storage, Sesame user portal, and the network connection starting from 1 gig up to 200, more than 1,500 Etherpoint based device. Okay. And here we're gonna talk about the data analysis and the storage. We have hybrid CPU, GPU cluster, half petabyte short-term storage, more than 30 powerful stations nodes, and the data service accessibility, data and metadata catalog ICAT. We called it SED, Sesame Experimental Portal, HPC, R&D integrated project, ASREN, and GANT. And here you can see some of technology we are using. So, why data management matters in Sesame? Today, data management in Sesame is because to ensure the integrity and accessibility and long-term provision of experimental data generated during research. So I'm not going to talk about this. I am here to share our journey with data with data management using ICAT. It's a start in the 1 year ago. In Berlin with Andy and all people. It's our first time having face-to-face meeting for the ICAT. Then today we have a running portal and the users can log in and see their data and either explore it and share it. Here's the interface. We have Sesame Data Portal. The interface is collaboration from ESRF. We take their data portal. So we installed it in our servers, then we run it. Okay, the Sesame Experimental Data Portal, as I told you, it's a SED, published in the URL sed.sesame.org.jo. It's easy to log in and have a friendly user interface. Okay. The key objective of data catalog service. So we make sure to make the data management easier, improve the data access, and ensure compliance with FAIR principles, support collaboration, integration with other existing systems we have. So I'm going to talk a short story about that. Today, Sesame have published data policy. So in our data policy, that applied on the SID data portal. So with the FAIR principles, so I think we're going to achieve a real-time data access and browsing. And about the ICAT metadata catalog, scientific data management, cataloging and discovery. That's what I'm talking about here. So, in this slide, I'm going to talk about the DataBeam pipeline overview. So, the whole story is starting from the beamline scientist user. He needs to be registered in the Sesame user portal, which is SOUP. There is two types of research happening in Sesame. One of them is in-house research, and the other is beam time. Then, if the beam time accepted and the proposal accepted, then go to the synchrotron beam and detectors, etc. There is something we called IBM JFS short-term storage, STS, taking the data from acquisition. Then there is a file sharing access, NFS SAMPA. Here we have backup and archiving software is under construction. We're actually looking for a good solution shaped and give us our needs. So even though the long-term storage LTS, which is archiving tapes, we have it already installed in our data center. But we still need to maintain and develop. Here is you see the ICAT data portal, and it's web-based, as you know, and it's applied the Sesame data policy. The link here is it, and then the user can access the data portal and see their data. So our story here is we have this data portal, and our target is to make the users, when they have a beam time, to log into the portal and go to the proposal number and seeing the data live, starting from the minute one. So we have additional features. I'm going to talk about it in the next slides. First of all, here is the Sesame experimental data writer, which is SID. SID is implementing by data acquisition people. They are two persons, Mustafa and Brahim. They developed an in-house project. It's responsible to generating data files and data sets and the raw data for the experiments, collecting from machines or detectors. Here is the SID, how it is work. The user experiment, enter just the proposal number, if it's correct, and then accepted. Scheduling for the day, continue for DAC process, which is starting generating all the files needed. Okay, the SDI, which is data ingestion workflow in Sesame. I'm going to talk to data comes from SID writer, as I mentioned before, from the data acquisition people, stored in the short-term storage, STS. Then we have the SDI Python code. It's act like an agent, watching the path, where is the experiment is, and start ingesting these files into the ICAT database, ingesting all the data, metadata, and raw data. So here is, as I told you, the data ingestion workflow, SDI, is a Python code act as an agent, watch the change that happened in the STS inside the location of the experiment at the real time. Here is the data types of Sesame. We have 3 types of data, starting from metadata comes from the SOUP, Sesame user portal, which is include the safety information, the names, and the whole information for the experiment. The other type of data, the metadata, comes from the experiment itself or from SID writer. And the third type, it's the raw data comes from Beamline and generated by SID writer. Data storage at Sesame. As I mentioned, we have now 2 types of storage for the SID, Sesame Experimental Data Portal, which is the first one, the short-term storage is STS. It's a file storage within half petabyte, effective configuration with GBFS file systems, and the other one, it's the long-term storage, which is LTS. As I told you, it's like a tape library based unit with on expansion unit, IBM tape library. It's around more than, say, 1,080 terabyte. And now we're going to talk about the remote experiment at Sesame, how the users can log in through and submit, as I told you, the first, the SOUP portal, then continue the whole process till he using the no machine to access the workstations in the Beamline. Okay. Now, I'm going to talk about the features in the SID and Sesame Experimental Data Portal. So we had a collaboration with the people from ESRF. Then we have a chance to take some good features from them. One of them is the HDF5 file viewer. Here the user, and we have, as I mentioned, the tomography beamline, which is beats. So the users can browse and see the HDF5 file through the portal. And the other type of features we have, it's like the e-log book. Here's the capture of e-log book in Sesame. The users can take notes during the experiment. There's many challenges in data catalog at Sesame. And first of all, as I mentioned, we are only 3 persons in Sesame computing group. We are fighting to achieve our goals and Sesame vision. The other point is the high prices of technology to keep adapt. And then hardware infrastructure, interaction between Sesame user portal and SID portal. It's a really hard thing. Security and privacy. Okay. I think I have just 2 minutes. I'm going faster. So lessons we are learning. In my opinion, the best things to do is to ask the professionals and the old people. They have experience in that. And this is our case. We have many collaboration with HZP, Rolf, and ESRF, and people from STFC. Collaboration and support, as I mentioned, support from ESRF and EU projects such as BEATS in Sesame, contributions from STFs and HZP, and the training experience. Here's some links. Thanks if you have any questions.
Okay, thanks. Very interesting, and I'm glad that you're doing such cool things.
Thank you.
Your last slide mentioned high costs, but you use Oracle database, and you mentioned window machines. Did you consider using open source alternatives? And I mean, I know there are debates about total cost of ownership of these things, but from my experience, open source allows you to significantly reduce the costs of software and infrastructure.
Yes, sure. Actually, thank you for this question. One of Sesame main goals in computing group, we are almost always going to the open source technologies, such as our operating system is based on Rocky. It's an open source. So, but sometimes there is a cost for like dealing with the software, backup software for the SID data catalog. And it's a really huge amount, and you need to pay a lot of money. Even to buy some hardware stuff like tape libraries and GPFS files, storage. It's not easy to deal with, especially in some financial issues. So that's it. Thank you.
Let's thank the speaker again.